Okay, we are on to number 5, which involves a proof that negative 1a equals negative a. It's probably a fact that everybody watching is going to say, well, of course it does. And you're right, we're just going to prove it using the little math axioms that they kind of build our math system upon. When you do proofs, you have to justify every step you take. They ask specifically in this question, they ask about step 2 and step 6. Recognize that when I started off, that very first step was to write something that has to be true, because I just copied this thing exactly as it was twice and said it has to equal itself. There actually is a math property for that. They call this the reflexive property. Reflexive, kind of like looking in a mirror. If you look in a mirror, you see your same image. Well, it's kind of that. It's the same thing. Both sides of the equal sign, identical, has to be equal to itself. So reflexive property. So that can't not be true because we just accept that as an axiom. From there, they start making their changes to the right side. They're not messing with the left side. So at the end of the day, these things down here, this thing has to be the same as that thing. And I didn't write down all 7. It was the thing we're trying to prove. Number 7 has 3 dots and a triangle that I'm writing right now. Those 3 dots in the triangle like that, they mean therefore in math shorthand. Therefore, this equals that, which is what we're trying to prove. If you don't end up with exactly what you're trying to prove, you're not quite done yet. You never want to stop the proof one tiny step short. Don't make the instructor or anyone else take that last step, no matter how small and elementary it looks. You're trying to prove that, it should be your last line. Anyway, so I don't know that they're going to ask about number 2 and number 6 on your actual real test. I'm going to go ahead and put dittos all the way down because this left side is the same as what we wrote. Because I don't know if they're going to ask specifically for step 2 and step 6, we're going to talk about them all. Starting with step 2, I guess I actually started with step 1 and told you what that was, reflexive property. But when they say step 2, they're referring to from 1 to 2. I'm going to change that to a different color to distinguish. Don't have my purple one. There it is. So from step 1 to step 2 is what they are referring to as step 2. And I want to look at what they've done for that. They messed with the right side, so they took the negative 1a plus 1a rewrote it that way. Real quickly, don't interchange upper and lowercase a's as a general thing if they have meaning. Their lowercase a has no meaning. I just didn't like writing this because is it the word or is it a? So I made it uppercase. There's no meaning to these, so it doesn't matter. But as a general thing, don't swap out upper for lowercase. Anyway, what did I do in going from here to here? I did something that if I look at it from this direction, here to here, I'd look at that as being the distributive property of multiplication over addition. A lot of times math words kind of mean the same thing they mean in English. Well, if I look at this, these parentheses is sort of forming a grouping, like a room. This is like negative 1 and 1 are both inside the room, and a is being distributed to both of them. It now goes with both those numbers, negative 1 and positive 1. And that's kind of what a distributive property does. It gives this thing here on the outside to everything on the inside, so distributive property. When you actually go from here to here, they call that factoring because we rewrote this as 2 things being multiplied. Word factor means you're writing things as 2 or more things that are ready to be multiplied together. They didn't ask us what math thing we were doing. They asked us specifically for a property. Distributive property is pretty much written this way. So when I go from here to here, this is kind of a thing, negative 1 plus 1 equals 0. As a general concept, if I give you some weird shape and we don't know what this is, and I give you that same weird shape with a negative sign in front of it, the negative and all this stuff, the negative kind of signifies that it's the additive inverse of that. And that means that if we add them together, we should get to the additive identity of 0. So even if I don't know what these things are, if they're identical and one of them has the negative sign, they are additive inverses, which means that when we add them together, we're going to get a 0, and they will always put parentheses around those, like right here. These parentheses serve no purpose, they just make it look a little prettier. So even if it weren't the number 1 is a special number in math, it's the multiplicative identity, and you kind of need one of those. So it's a special number in math. That's the additive inverse. If we add them together, we get this 0 here. So when we do that, additive inverses, somehow that would be the description of what you would do from there to there. They don't ask about it. Multiplication property of 0 is what's going to take us to here. With simple math, just 0 times a is 0. We all know that. This is what I was talking about here. If I have an a, and I have an a with a negative sign in front of it, those are additive inverses, which means when I add them together, they equal 0, which is why that's a 0 there. And the math world does not like seeing a plus and a negative sign side by side, so they're pretty much always going to do that. They're not serving any mathematical purpose at that stage, except to tell us that our operation is plus. So they asked us about step 2. They also asked us about step 6, which is from here to here. And if I look at that, I'm going to do this real quickly, get rid of those again. That there is now on the left side of our addition. Right? They took this thing here and they just moved it out to the left, moved this into the right. So they pretty much did this with the a and the negative a. And when they did that, these parentheses that aren't really serving a math purpose, it's still the same thing here, same exact meaning. You can see I grabbed the parentheses that are on the right side of the plus sign, moved them to the left side. When you move things around, it's called commuting. Right? Like if you get in your car and you commute to work in the morning, it means you're getting in your car, you're driving, you're changing your location. These are locational sorts of changes. We took our left and our right and we swapped them out. And when I did that, I no longer have the 2 signs that are side by side, so I don't need the parentheses anymore, so they got rid of them. Would not be wrong if we left them in. So I could have them here if I chose. I could get rid of them here. They're both correct, but they moved them. That's commuting, and that's what this property is. From here to here, this is one that might not appear quite so obvious, but if I subtract it, remember I have this up here written down here, so I'm going to put it down. If I looked at this, I can see that both of them contain that plus a. And I can see that if I got rid of the plus a, it would leave a negative 1a over here on the left side of the equal sign. And it would leave that negative a right there on the right side. And the way to get rid of the plus a is just to subtract a from both sides of the equal sign. So if we just took this thing here and subtracted the a, we'd arrive at that. So that's all they did, they subtracted the a from this. So that's the basic things they did here. You just have to look at each step you have and say what basic concept of math justifies it. And it sounds simple until you do your first one, and when you do the first one, you're probably going to stare at something for a long time and go, well, obviously, but got to put a name to it somehow with the axioms that are in the course that you're using. And that was number 5.